Students, I am K.L. Janghel, Assistant Professor from Rungta College of Engineering and Technology, Bhilai, Chhattisgarh. So, today's topic on which I am going to deliver the lecture is winding in mining. With reference to mining industry, the winding means it is a transportation of main material from underground mines to surface through a shaft. What is shaft? While you are mining engineering students, you must have been taught about shaft. It is a vertical or steeply inclined more than 50-degree deep angle or inclination access to an ore deposit in depth, that is below superjacent ground, as per the definition of Metalliferous Mines Regulation 61. In case of coal mines regulation, it is 2017. So, the depth normally for underground mining is, thumb rule says that for underground mining we have, as soon as we exceed the mining depth beyond 100 meters, we should switch over to underground mining. But these days lot many bigger means of mechanizations are there, vast means of mechanizations are there. So, the mining becomes economical even up to 200 meters depth. That all depends upon the market value of the mineral being mined in the mines. If it is costly mineral, the depth may further go beyond even about say 700 meters to 1000, rather a kilometer even. Like in Chile, there is a diamond mines which goes down up to 1.2 kilometers. Okay. But normally the open cast mine remains up to 200 meters max, and after that the general trend is to go for the underground mining. That is why we mentioned the depth more than 200 meters generally. And even if the deposit starts at the depth of say 100 meters, then the shaft has to be sunk in such a way it will be touching somewhere at 150 meters to 200 meters depth, by making a level access to the ore body. There are different types of shafts windings. One is the skip winding, another is a cage winding. Cage winding is most common. Cage means it is accommodating men and material transportation both. How? The cage is basically a rectangular box on which the loaded wagons coming out of the coal mine can be mounted on a rail provided on the base of the cage, and it can be lifted up by winding system. At the same time, when there is no tub inside the cage, the men can stand in the cage, and the men can also be transported by winding system through the vertical shaft to the surface of the mines. Now, what is winder? Winder is a mechanical means. It is a mechanical means through which winding action is executed, implemented. Okay? I have told what is winding. I have told already what is winding, and now winder, for winding purpose a winder is needed. It is a mechanical means of winding operation installed on the surface or even underground at the midway for transportation through a shaft. It is a mechanism, it can be installed on the surface, it has to be installed on the surface necessarily for transportation from underground to top of the surface, and sometimes in underground also when depth of mining is more and the existing shaft winding is not of sufficient capacity, and if it becomes to enhance the capacity of the shaft winding, it becomes difficult. In that case, there will be a second an underground winding or extended winding from certain level to more depth of the deposit, greater depth of the deposit. So, there also a winder may be provided. This is the general arrangement of the drum winder. Drum winder means the cage winding. Normally, the cage winding is done with the help of drum winder. So, in drum winder case what happens, you can see on the right hand side on the top, there are two hoist ropes going. So, those two hoist ropes will be passing on the groove of the two headgear pulleys mounted on the top. It is a side view and only one wheel is visible, whereas on other side I am going to say on the back of the wheel visible now by drawing by having a drawing having the side view, there will be another wheel, there is another wheel on which another hoist rope is mounting. So, there are two hoist ropes going being engaged for winding in the shaft, and whatever the frame you are looking at, the steel frame, that is called the headgear frame. So, this also is having 4 poles on the sides, it is just shown one. So, it is around 5 meters wide, I mean to say each side is around 4.5 to 5 meters wide, the height is 26 meters roughly you can say, and on the top there is a bell plate provided. That bell plate is having a central hole, and there is something called self detaching hook in the cage assembly, cage suspension assembly on the top. I will show what is the in the next slide, where is the self detaching hook working. So, in case of that self detaching hook is just below the headgear pulley at the central place through which the hoisting rope is passing. So, there will be two different bell plates for two ropes. Why that bell plates are provided? There is a self detaching hook on the top of cage, on the roof of the cage there is a there is a suspension assembly, cage suspension assembly. So, on the top of that at the middle of that there is a something called self detaching hook. That detaching hook, in case of overwinding, that means when the winding is more than the deck on the surface where the man lands, if it is more than that, the winding takes place above that up to that extent, then the rope will be then the self detaching hook will be caught by the bell plate on the top, and the whole cage will be suspended, and at the same time the hoist rope will be released. So, that hoist rope will be not damaged under tremendous tension. So, that self detaching hook is provided to trap the self detaching hook literally and mechanically. So, that the self detaching hook rests on the bell plate, suspending the whole cage from that safely. In case of overwinding, the bell plate is provided. Okay. This is the mechanism in inclined shaft. You can see a headgear pulley is there here also, but in inclined shaft you cannot have the cage winding, because cage winding is meant for only vertical shafts, transportation through vertical shaft, winding through the vertical shaft. So, here you can see a skip at the mid of the inclined shaft passage shown going down, and the angle is more than what is the difference between inclined shaft and incline? See, the incline angle is hardly 30 degree maximum, or okay, it is 30 degree, 32 degree maximum, whereas the inclined shaft angle increases, and it is if the inclined section is having the inclined angle with the horizontal at the angle more than 50 degree, then it is inclined shaft, it is not the incline. Okay, because it is very steep. On the incline the man can descend down or can come up, but in case of inclined shaft it is not possible. So, here is it is a skip provided, you can see that skip is getting hoisted by the hoist mechanism on the surface of the mines, and between the headgear and the hoist rope you can see the bin arrangement, where the skip gets unloaded. From the bin there is a bottom chute, from that chute the material falls onto the belt and it goes to the crusher for crushing. So, this is the winding arrangement for skip transportation through skip. Obviously, in the skip, in the inclined shaft, the manpower cannot be transported, because to have the manpower transported through the cage which is normally taking the material, which is meant for taking the material, it is attached to the hoist rope. It cannot be converted to man riding. It is a material, basically material transportation riding, point number 1. Point number 2 is that it is too inclined through which the man will be transported through the skip. It can be done, it is not that it cannot be done. If a roof is provided on the top of the skip and inside that if there is a sitting arrangement, yes, it can be done, but normally it is not done, it is meant for material transport. And see, this is the skip, there is a D frame through which the hoist rope is tied, fixed rather, and the front wheel is thinner wheel and the back wheel is wider wheel. You can see how the wide width is looking on the rear wheels. Now, rear wheel moves on the two outer rails. There are total 4 rails, two outer rails and 2 inner rails. So, inner rails is guiding the front wheel, whereas outer rail is guiding the rear wheel. Now, when the front rail is bent as it is shown at the unloading point, the skip unloading point mechanism is there. So, when the hoist rope is pulling the skip, the front will be going down on the bent rail and rear will be mounted on the outer rail which has gone straight, unbent, which has gone straight. Okay. So, the rear will be on the upper portion and the front will be on the down portion, toppling the skip, and from its front portion as shown open, the material will fall into the bin. Advantages and disadvantages of skip winding: high capacity up to even 30 tons for material lifting, caters need up to deep workings. For deep workings also it is quite good, the skip winding, because in one winding, in one winding or in one hoist you can lift more material for the same travelled distance. The skip winding is more efficient so far productivity is concerned, because in cage system maximum in a cage a tub comes, maximum 2 tubs can be accommodated, but normally it is 1 tub accommodated. I am sorry, 2 tubs are accommodated at a time in a cage. 2 tubs means each tub is 1 ton. So, that means 2 ton is coming in one hoist, whereas in skip winding even 30 tons, particularly with bottom discharge skip, even 30 tons can be wound up or hoisted up through winding system, and for the same distance the tonnage lifted through the same timing will be much more. So, productivity will be high. So, this cage winding is having limitation of productivity, it cannot produce more, because maximum it is accommodating 2 tubs in a cage, whereas in case of hoist it is 30 ton material can come up at a time. Normally it is around 8 to 12 tons, normal case, normal skip size, it is 8 to 10 tons maximum, okay, 8 to 12 tons. And it is not suitable for man winding, as I said, particularly in the vertical discharge type. There is no place for man standing, so it cannot be used for man winding. The inclined one, on the inclined shaft, the front open overturning top of skip can be used for man winding, but again where the man will be coming, where the man will be decking, because its bending point is on the rail bend point as shown. So, there it is for bin loading, not for man unloading. So, it is difficult to use the skip for even if it is an inclined shaft and it is overturning type of skip, it cannot be used for man winding. Speed of winding is slow. See, it is advantage and disadvantage we are discussing about skip winding. Skip winding, because it is heavy material lifting 30 tons at a time, sometimes quite a big skip is being used. 30 ton means 30 ton dumper, Hiva dumper you can think of. So, but that is very unusual size. Normal size is around 8 to 15 tons maximum, not 30 tons. 30 tons is quite huge winding. It is it is nowhere used nowadays, because there is risk also involved. More the heavy weight is lifted up vertically up. Okay. Anyhow, so speed of winding is slow. It is not very fast, because suddenly suppose somewhere suppose the power goes off, there will be a heavy jerk on the rope because of the high capacity skips, which is accommodating quite a huge ton of ore. So, that way it may cause the rope damages or even rope breakage even, and then subsequent accident. So, the speed has to be very slow. Okay. Next. Now, what do you mean by speed slow? See, I have seen the shaft even 4 meters per second winding speed in case of cage winding. In case of Cope winder, it is 6 meters per second, quite a huge speed. But in case of cage winding, it may be hardly 1 meter, 1.2 meters, 2 meters maximum. Okay. That means below the cage winding speed. The normal speed with cage winding is 2 meters per second. It is suitable for inclined shaft, but needs longer track winding than vertical shaft, thus more time taking. For stowing, filling of goods etc., carrying material through skip is difficult, because loading and unloading facilities are not available at pit top and pit bottom. Skip winding, normally what happens? The material falls from the bin, and after that it is getting hoisted up, okay, the skip. I will show you the mechanism. Whereas, there is no receiving bin for carrying the material from pit top to pit bottom. You can do it in tub, because tub is quite flexible. It can be just pulled or pushed on the tracks to go anywhere. Whereas, skip material unloading is a different mechanism. It cannot be unloaded easily, because the skip once loaded can be unloaded only at the pit top. It cannot be unloaded at the bottom, particularly inclined one, that overturning skip, that is very difficult to, there is no question of unloading at the bottom, no question. The mechanism is not permitted to get installed in, it is such a mechanism. Similarly, bottom discharge. How can you load the material from top at the pit top? There is no arrangement, because pit top is only for unloading the bottom discharge skip. It is not for loading the bottom discharge skip. So, it is normally it cannot be used for other material transportation from surface to underground, like wooden leggings, battens for supports etc., and roof supports etc., and material underground as for the open, and its body is long. So, it cannot be accommodated, and it cannot be unloaded. The most difficult thing is it cannot be unloaded at the pit bottom. So, this is just one of the diagrams. You can see on the right hand side there is a shaft, and there are two skips shown with tiny small skips are shown. So, that is connecting to different levels for underground stoping. This is metal mining 3D block, and on the top you can see surface mining. After that, a barrier of 50 meters or 100 meters is left, and after that underground mining starts. Basics of drum winding. See, you can see separately a drum, blue color, bigger diameter on the right hand side, and there is a base provided on the surface, that is a surface line. 9 is the surface line, and 8 is the hoist rope. Similarly, 5 is the hoist drum, and 4 are the 2 numbers of headgear pulleys. Actually, this has been shown different just in the drawing, but both the pulleys are remaining at the same level. Mind it, both the pulleys remain at the same level. After that, there are cages shown suspended from that in the shaft. There are 4 guided pulleys shown with the blue lines. Just 2 lines for one cage is shown from the side view, but on the other side there will be another two guide ropes. These guide ropes are supported from the headgear frame as shown, and this at the 4 corners of the cage, the guide ropes will be suspended with a suitable weight or anchoring at the bottom of the shaft. So, that cage whilst getting hoisted or lowered, will be not shaking, nor it will be twisted, nor it will be twisting, nor it will be spinning because of any twisting action of the rope. So, it is tied, it is supported, rather not tied, it is supported on the four corners. The cage is supported on its four corners on the top to bottom with four guided ropes. It has been shown by blue line hoist ropes only, and you can see the to hold the guide ropes with respect to the side of the shafts, there are some pegging arrangements shown. So, this is the general drawing for the winding drum, and do not understand that both the headgear pulleys are at different levels. No, it has been just shown. So, there are two pulleys just to indicate that it has been shown like this. It is made of cast steel having groove diameter 105% of the hoist rope diameter on its vertical plane of rotation. Rope diameter is suppose say 40 mm, okay. The hoist rope diameter is 40 mm. In that case, the headgear pulley will be at what diameter? 400 meter, 4000 millimeters. That means 4 meters diameter. Okay. More than 4 meters diameter, 4.2 meters diameter. Such a huge headgear pulleys will be there on the top. Why it is so? So that there will be no bending stress on the rope, more the diameter of the headgear pulley through which the rope passes. If the diameter of the rope is more, then the diameter of the pulley will also go high, so that the bending stress on the rope will be not coming due to any sharp bend if the pulley diameter is small. It is mounted on the top of the headgear supported by roller bearings fitted in journals. Journals, you understand? The bearing housing is called the journal in mechanical engineering on both sides. Its diameter must be as much as possible, at least 100 times the rope diameter. Okay? The wrap angle of the rope on pulley 120 degrees at least, or say 1/3 of the rope contact on pulley groove. Okay? That means, whatever is the circumference on the pulley is, so 100 it is 360 degree complete pulley angle, circumference angle. So, 120 degree means 1/3 of the rope contact on the pulley groove. This is called fleet angle. What is this? Is the plan view of the headgear pulley and the drum, the hoisting drum. On the right hand side, the drum has been shown with two ropes, hoist ropes going, and pulley has been shown, two pulleys have been shown in the plan. Now, the groove, it is holding the rope, but you see the rope may not be in the same alignment of the groove of the pulleys, because the rope is wound on the drum also. So, the drum the rope cannot get wound on the drum one above the other. Okay. The one lap cannot have the another lap on that, and third lap on the third lap on the first lap. No, it cannot be done. It is just side by side. The laps of the ropes are side by side in contact, in intimate contact. So, the rope is bound to make an angle with the axial plane of the pulley groove, okay, vertically, and that angle is small, and that should not be more than 1.2 degree. Okay. 1 point maximum 1.3 degree or 5 degree it has been shown. So, but standard is 1.2 degree, it should not be more. So, accordingly the distance between the headgear pulley center and the drum has to be adjusted. This is headgear system, and its different tension system has been shown how it is working. Winder location, it must be installed by grouting on a firm and strong ground. So, the ground has to be very strong. Hoist rope angle not to exceed 45 degrees with horizontal normally and 35 to 40 degrees normally. Beyond back leg headgear distancing of at least by 10 meters. Rough terrain should be avoided. Any reversible or subsidence area should be avoided, or any geological disturbance area should be avoided. Entry of smoke from the engine to the shaft, because of there is a ventilation fan also. If it sucks the engine smoke from the winding engine room, then the ventilation will be disturbed, it will be polluted air going inside the ventilation inside the mine, should be avoided. No bushy or forest area should be there, no marshy, that means no wet ground should be there, which is sinking ground basically. A marshy means the slushy material, okay, slushy muddy material should not be there around, not on explosive magazine nearby, beyond the working zone of the underground, it should be beyond the working zone of the underground, and no disturbance due to any blasting inside the ground, inside the mines, or rock burst even. Okay. What is rock burst? Sudden failure of the roof. It happens in metal mines. What happens? Coal mines strata is weak, so it will be showing crack and then fall of roof within very short span of time. But in case of metal mines, the rocks are igneous and sometimes tough metamorphosed also. So, the roof is storing the pressure from the top due to greater depth. You understand that the metal mines depths are normally more than coal mines. So, strata column is high on the top on roof, and the roof material, roof rock is storing that energy because of its higher tensile strength, and even compressive and tensile both strength, you can say both are responsible for holding the rock above. So, that weight will be going on increasing and increasing, there will be sudden burst one day because of high potential energy is stored for longer time in the rocks, in the roof of the, in the roof rock, in the hang wall rock of the deposit while mining, that will burst suddenly with a huge sound. That sound is even sometimes heard on the top of the mines also, on the surface. So, that is called rock burst. Okay. Similarly, fire etc., no marshy ground etc., and subsidence etc., and not for any important civil structure, if it is required, then only we should locate the shaft there, because shaft is going to serve the purpose of mining for throughout its life, because if the life is say 20 years deposit, 30 years deposit, yes, then the shaft has to serve the purpose for 30 years, not lesser than that, because shaft sinking is quite a costly method and it is time taking. So, it will be disrupting the coal mining or the metal mining production if it is getting damaged for any other reasons. So, that is why these precautions are to be taken. This is the you can say on the right hand side, left hand side are the two, see the extreme left, there are two plates, two inner plates of the detaching hook put as the left hand and right hand like this. Okay. Two plates, see this this thumb is this side and this thumb is this side. So, both will be placed like this. Okay. That is the plate shown on the left side. Okay. This will be placed like this. Similarly, the right hand plates are the outer plates that is covering this plate from the outside like this. Okay. And then it is hook system is made. So, the bell is getting, you know, bell is trapping the self detaching hook, see, and the top, the from the D link above the rope is getting detached, the D link along with the rope goes up, and the detaching hook from the bottom, the D link there, from there the cage is suspended, and that will be held safely without falling. The cage will be held safely without falling from the bell plate provided at the top of the headgear, just below the headgear pulley. This is the cage assembly. You can see there is a self detaching hook. See on the top you can see the rope, hoist rope, then rope couple, then D link. After that you can see the self detaching hook, a small shape is shown. After that again D link, and then distribution plate or triangle plate, after that chains, like that. This is the general, and bottom horizontal line shown is the top of the roof of the cage. After that there is a bottom portion of the cage in rectangular box, that is not. Essentials of winding in a shaft: headgear frame is must, as I have told you, winder is must, as I have told you, winding machine, the drum should rotate and pull the rope, one rope is released, another rope is pulled by the hoisting drum. Okay. So, that one side cage is coming up, another side cage is going down, it is a drum like this. So, from the top, if it is rotating, the rope is going like this, and from the bottom the rope has gone. So, this top rope is getting pulled, that means the cage is coming up, and this is getting released because of the reverse direction, and it will be lowering the cage, empty cage, okay, and loaded cage will come up. This is the suspension cage, and with the different safety arrangements of the cage in a shaft. The two parallel lines shown on the extreme two ends on left hand and right hand are the shaft walls. This is another type of winding. I have till now discussed about the drum winder. This is the Cope winder. Cope is basically friction winder. In case of drum winding, hoist arrangements are on, there are so many laps of ropes, okay, as I have shown in the previous diagram where the fleet angle was being described, explained. So, in that slide I have shown you that there are several ropes going, but in case of Cope winder there is a single pulley, on which the rope is just passing like this, and two cages are suspended, that is all. Now, that here the lap angle is more, it is 120 degree, sorry 100 I am sorry extremely, this is 200 degree, more than 180 degree, and in case of drum winder the lap angle was 120 degree, not more than that. By design it was not possible to go for more than 120 degree, but in case of this Cope winder, and with the case of this there is a guide, a snub pulley sort of thing given on the left hand side just below the main headgear pulley, the Cope pulley, the Cope winder pulley. So, you can see the two cages suspended from the rope, and the rope is sort of endless. Endless means from the bottom it is getting attached, from the bottom of the other cage it is getting attached. See, there is another balancing rope. Why the balancing rope is there? Because here the motor is attached on top of the pulley even, that is all. On top of the pulley the motor is attached on the headgear frame only, there is no separate winding house. In case of head frame mounted friction winder, this is also called friction winder, and Cope is the name of a scientist, and it was just designed by him, German scientist, yeah, if I remember correctly. So, he designed this, and this is a friction pulley basically, on which the rope, single rope lap is passing, and that single rope lap is passing through the groove, which is having the wooden, the tough wooden pine, not pine, is it? It is different wood, and that is described here. The tough lining of the groove is given on that, so that friction increases. Okay. So, friction is mu is 0.2, it is kept more than that, so that the holding of the rope to lift the cages on both sides, the friction has to, there has to be proper grip of the rope on the wheel, on the top, this friction pulley on the top, which is also working as headgear pulley. Why the balancing rope is given? So that the, you know, that when the cage, one cage is coming down, the rope length is increasing above that, and the on right hand side the rope length on the top is decreasing. So, there will be the rope weight on the left side will be more, and the rope weight on the right side will be less. To compensate the whole thing, the another rope, the balancing rope has been provided from the bottom of the cages. On the right hand side, the drum winder is shown. Two types of winding, as I told. Cope winding also there are two types. One is the headgear frame, on the top the motor and pulley, everything is mounted on the top. Another, there is a platform provided on the headgear itself, not necessarily on the ground, and that will be winding the this one. Okay. Advantage of Cope winder with respect to drum winder is that it is more capacity to hoist, then lighter in construction, unlike the drum winder, because in drum winder there is a huge drum required, then there will be two different pulleys, here single pulley is working for up and down. So, like that, and power transmission is easy because of the balancing rope. It is easy also to save the power because of balancing rope. 0.35 to 0.5 is the friction made, just see point, it is more than 0.25 the coefficient of friction. The suitable for heavy loads in deeper shafts, it is good for deeper shafts. Static torque is constant. Then sometimes double ropes are parallelly used to have the multi rope winders to have the more strength, but in that case the balancing rope will be equal to the section of the balancing rope, weight per meter of the balancing rope should be equal to the weight per meter of the rope fitted on the hoisting side, okay, above the cage. This type of winder is provided in Sudamdi Munidi coal mines of Bharat Coking Coal Limited of Coal India Limited in Dhanbad. Multi-level winding is possible. I will show the diagram. Either factor of safety has to be taken more because single rope is there, and in case of multi rope the factor of safety will go down. As I have said that 20 times the factor of safety is taken in case of man winding. What is factor of safety? Suppose a rope is pulled, suppose a rope is pulled from both sides, and you put a spring balance, okay, and pull it from both sides, and the reading comes while after reading of suppose 10 kg load it breaks, okay, and the designed, then I have to design it for 20% giving factor of safety 20%. That means I have to design it for 8 kg load only, then the factor of safety will be 20. That means 10 minus 8 divided by 10 is the factor of safety 20%, okay, that is the meaning. So, types of skips, again I have told that skips there are there are two types, one is the overturning type or the front discharge type, another is the bottom discharge type. See, I have shown this diagram to you earlier also in the previous slide. The rear wheel is mounting on the straight rail and the front wheel has gone on the bent rail. So, though the skip has got turned, the bottom portion is the normal position and top position top one is the overturned unloading position of the material of the skip. So, this is overturning type of skip, okay, and on the side the rope has been shown on the top, on the back of the rear wheel gone up, there is a rope shown, hoist rope, which will be turning the skip down, and as soon as the rope is released, the center of gravity on the back side is more and material has been removed from the skip. So, the skip will go back and then it will go back to the mines again on the inclined shaft. This is the skip design dimensions. Bottom discharge skip, how it is that? See, I will show you. See, at the bottom portion, on the top there is a hoisting arrangement and plates etc. for holding the skip, which is vertically going down and it is long also. The gate is there, just see it, the gate position is open in case of right hand diagram, left hand it is closed position, and the whole frame is holding the skip centrally, you can see the by dotted line. So, the while loading the skip at the bottom, shaft bottom, where the material production has taken place at different levels, the skip bottom gate is closed and remains closed. When it goes to the top, it hits a latch, it hits a triggering system on the top, and the latch which is holding the bottom door closed in closed position will be hit, that latch will be hit by the triggering bar on the top, and the gate will be opened because of gravity, and then it will be unloading the material into the bin on the top. This is the actually on the top, this is on the pit top arrangement, where the skip is getting unloaded from the bottom portion to a chute, and chute to belt on left side it is going for the processing system. See, here also the skip is there, which is unloading the material on the belt from the left hand side chute, it is bottom discharge type. This is the previous two slides were shown for the pit top arrangement. Now, here it is the pit bottom arrangement. See, the skip has gone down to its height on the top from where it is open. it is remaining open on the top, and material is getting discharged from the bin on the right hand side system through the beds, and the material is falling into the skip, when the skip door at the bottom is closed. The bottom view is the plan. The bottom view is the plan of the same arrangement. This is the Y chute arrangement for loading unloading system of the skip. The gate is turned on left side and right side to open the Y chute from the right hand side and left hand side respectively. The hydraulic jack system has been shown horizontally, that is operating the gate to bring to left side and right side. The hinge is at the center of the A part, okay, at the bottom where black spot is shown, big black triangular spot is shown, that is the hinge system. So, door is getting opened on either of the sides. Okay. Next, this is Y chute. Next, so this is the again there is a pocket bin, that is called pocket bin at the bottom of the mines at the level which is just having capacity of one skip unloading. Okay. That means, what if suppose the skip capacity is 10 tons, the bin will be having the material of 10 tons only. As soon as the skip comes, it will be loading the skip with 10 tons of material, and the material will be finished. So, that there is no chance of skip overloading and material is spilling out of that to and going to the shaft bottom, which will jam the shaft bottom. These are the advantages, disadvantages of the two types of skips. You will be understanding very easily, nothing big, it is self explanatory. Types of Cope winders. See, the ground mounted, tower mounted, that single rope, multiple rope, location of head shifts, over and under, side by side, number of levels served, multi level, single level. Cope winder principles of working, as I have told, the lap angle is more than 180 degree, and the friction is kept mu is kept more than 0.25, the coefficient of friction. This is the basic principle. Cope winder principles of working, again it is continued, just slight descriptions are given for your exam purpose, you can read it, there is no problem. Technical features, maximum productivity, as I have told, because its capacity, skip capacity is high in comparison to tub. The tub holds only 1 ton, maximum 2 tubs comes in a 1 cage. So, in one winding only 2 tons is going up. In case of skip, even it can go up to 20 tons, even can go up. Just a minute. Easy installation and maintenance, boltless fastening of the traction sheave linings. Yeah, there is no bolt fastening, single sheave of the cast steel can be used. Wear free, that means the it is we are talking about the this headgear pulleys, etc. In case of drum winder, there are different segments of pulleys are there which are fastened by bolts. In case of Cope winder, the single pulley can be used without any bolts, etc. Made of steel, okay, cast steel. And these are the technical data: drum diameter 1 to 8 meters, number of ropes 1 to 10 meters, payload. These are technical data depending upon the requirements. See, the pulley sprocket system has been shown, single casting on the right hand side at the bottom, and on the groove the polyfiber or some asbestos or oak wood, that is given as lining to increase the friction, coefficient friction between rope and the pulley groove. This is just a simplified diagram of this ground mounted friction winder. This is again the diagram, just line diagram to explain. Benefits of tower mounted Cope winder: it takes less space, it is faster in speed, and it is very lesser assembly, easy to maintain. Transmission of power is easy, because there is no other system coming in between. Straight way from pulley to rope it is getting transferred, okay, because pulley is rotating, pulley is working as the drum as the winding torque imparting mechanism instead of the hoist drum. So, this is the formula: T1 by T2 on either side of the tensions, and it should be less than or equal to e to the power mu theta. What is mu theta? E is the Naperian system, it has been taken from there. T1 is the tension which side, the loaded side, T2 is empty side, mu is the coefficient of friction, 0.2 and theta is the angle of lap 200 degree normally. It is the capacity of skip. See here it is shown 12 tons. See, I was telling you diameter of rope is 29 millimeters. That means its headgear pulley will be how much? The pulley on the top 100 times, so around 3 meters. See the rope kg per meter. Acceleration time, then rotating parts. These are all technical data. Multi-rope winding is possible, and lesser stroke it is more safer also because of multi-rope winding. Single rope dependency is not correct. So, multi-rope winding is providing safer system and sturdy system to wind more capacity of the skip instead of distributing distributing the whole hoisting load on one rope. So, it is more efficient system so far productivity is concerned. There is no need of cap system on the platform, and then there is some better system, straightway decking system. Disadvantage of Cope winder is that it is multi-level winding, two more different driven pulleys are required, whereas in drum winder it is not so. Wherever you like in drum winder it can be stopped anywhere, but in this case everywhere it cannot be stopped. It can be used in vertical shaft only, cannot be used for shaft sinking, because shaft sinking is an initial process, and this Cope winder cannot be used because there is no headgear system in the beginning. And also even if headgear system is there, this Cope winder is a special mechanism, it cannot be used so easily by making platforms, etc. Deeper shaft, it is good for deeper shaft, balancing tail rope is there. Then because deeper shaft, what happens on the lowered cage, the rope length is much more than the pulled up cage on the top, so that is causing imbalancing of the load. So, in deeper shaft particularly, so this particular Cope winder, because it is having the balancing rope at the bottom of the cage also, so that is compensating the imbalancing of the rope on the in case of drum winder. So, this Cope winder is much more suitable for deeper shafts, that means more than say 700 meters, 800 meters depth. This is multi-rope winding diagram. See, this is multi-rope winding drum. This is multi-level winding. You can see there are two levels. So, left hand side is serving for level 2 and right hand side Cope winder is serving for level 1. Thanks to all of you.